Alright, hello everyone. I'm Maya and this is Mathelingual again. Now, the last video I went over a word problem involving solving an inequality. Now I'm just going to talk about and show two regular non-word problem examples where we have to consider if the inequality has no solution or if all real numbers satisfy or make true the inequalities. Okay, so example number one, let's jump into it. Negative 2 times 3x plus 1 is greater than negative 6x plus 7, okay? First, we're going to use the distributive property. Just multiply this out. Negative 2 times 3x is negative 6x. Negative 2 times positive 1 is negative 2. And then we still have the negative 6x plus 7 on the right side of the inequality symbol. We simplify this further by adding 6x to both sides. 6x cancels out, but now we have negative 2 is greater than 7. That's wrong. Negative 2 is not greater than 7. Negative 2 is negative. And we always consider a negative number smaller than a positive number in this case. The only exception really would be like if you considered absolute value, but even in that case, 2 is not bigger, okay? But anyway, negative 2 is not greater than 7, so this is never true. Negative 2 is never greater than 7. So it's false, which means this inequality has no solutions, okay? Because you try to simplify it with the variables and both sides, the variables cancel out, so you're just left with two constants, negative 2 and 7, and that's wrong. So no solutions. Okay, now our next example, number 2. Okay, 5 times 2x minus 3 minus 7x is greater than or equal to 3x plus 8. Okay, so again, we're just going to multiply this out. 5 times 2x is 10x. 5 times negative 3 is a negative 15. Minus 7x, bring that down, is less than or equal to 3x plus 8. Okay, now we're just going to combine like terms. This is something I've covered in previous videos, so if you're a little unsure of how to do that, I recommend going through some of the other videos I've got. I'll put a link in the description. I've got a playlist just for these videos because it helps me keep track of what number we're on. Not that it really matters, but I just don't want it to be like, you know, number 1 this, number 1 that, right? I just like to go in order of what I've been doing. So anyway, 10x minus 7x, that is 3x. Now we have the minus 15 still, and then we have the less than or equal to inequality symbol, 3x plus 8. Now we're going to subtract 3x from both sides, cancels out. Negative 15 is less than or equal to 8. Now notice we end up with two constants again like up here, but the difference is this is a true inequality. This is true. Negative 15 is less than or equal to 8, right? It's not equal, but it is less than 8, okay? This is true, okay? So this is true, whereas this was false, okay? False, this was false, this is true. So since this is true, this is always true. Negative 15 is always less than positive 8. So that means this inequality, for this inequality, all real numbers, I'm just going to abbreviate here, all real numbers are solutions, okay? All real numbers are solutions. Okay. So that basically sums it up. When you come down to two constants like this, and it makes an untrue, a false statement, a false inequality. So like negative 2 is greater than 7. That's not true. That's false. No solutions. But if the constants in the inequality do make a true statement in some way, negative 15 is less than or equal to 8. That is true. That's always true because negative 15 is a lot smaller than positive 8. Okay. I mean, of course, I guess you could argue a little bit more depending on if you touch base on like absolute value equations, absolute value inequalities, but we won't be getting into that yet. We will in the near future, but not yet. So for now, negative 15 is and always will be less than or equal to 8, which means it's true. So for this second inequality, all real numbers are solutions. So basically sums it up. And I think I just repeated myself saying that. But until next time, I'm Maya, and this is Mathelingual out.